The latest innovation in the Rainbird's irrigation family is the XFS subsurface drip line with copper shield, designed specifically for subsurface drip irrigation. Patent-pending copper shield technology protects the emitters from root intrusion. The pressure-compensating emitters provide a consistent flow over the entire lateral length and come in a variety of flow rates and emitter spacing. These emitters are grit-tolerant, self-flushing, and factory installed within the most flexible drip line tubing in the industry. A basic drip line zone will have a water source, a control zone consisting of a valve, filter, and pressure regulator, drip line, an air vacuum relief valve, and a flush valve. The techniques used for this installation can be used to install XFS drip line on any small or medium turf or landscaped area. A valve, a filter, and a pressure regulator must be installed for each zone. This trencher was chosen because it could accommodate both 4-inch wide and 1-inch wide trenching. It also can dig 4 to 6 inches deep. The supply line, supply header, and exhaust header locations are trenched using a 4-inch wide attachment. The supply line is assembled in the usual fashion, and the trench is filled. Next, the lateral lines are marked. A well-designed drip line system will create an even wetting pattern. A 12-inch section of pipe is used to evenly space the guideline. Then the lines are marked with paint. The factors that determine an even wetting pattern are soil type, emitter flow rate, emitter spacing, and lateral row spacing. Lateral row spacing for this zone is 12 inches. Next, the trencher is fitted with a 1-inch wide blade, and trenching begins for the lateral lines. This installation is using XFS subsurface drip line with an emitter flow rate of 0.6 gallons per hour and emitter spacing of 12 inches. While trenching continues, the drip line is also being installed. Notice the technique being used to take the twist out of the drip line, how the self-extracting coil feeds out smoothly without need for additional equipment, and how the tubing lays flat. Now the drip line is placed into the trench. Both ends are cut and temporarily sealed to keep out the dirt. Soil is added to hold the tubing in place at the bottom of the trench until it can be properly filled. Filling the trenches and evenly compacting the soil is critical for consistent water dispersion. The goal is to return the soil back as close as possible to its original compaction. The lateral lines will be connected to the supply and exhaust headers using barbed insert fittings. Each end is cut to length A barbed fitting is inserted, and a section of pipe is installed that will retain proper lateral line spacing. The process continues until all lines are connected. 2 additional components are installed that are absolutely necessary. An air vacuum relief valve is installed at the highest point in the zone to allow air to escape at startup and prevent back siphoning at the emitters after shutdown. And a flush valve is installed at the low point in the exhaust header. As an option, a Ziri-pop can be installed as a visual indicator that the zone is operating properly. As the remaining trenches are filled, special care is again taken to match the soil type and to compact all backfill to the original density. After a final flush of the system to remove any debris, the subsurface drip installation is operational.